Hi everyone, and welcome back. And this video is going to be a teardown on this little beauty here. This is a MK2, a Mark II Universal System it's called, and yeah, that's his model number. It's an MK2, that's what it is. Basically, it's a 4 instruments in one steel box. So you've got a power supply down here, signal generator, multimeter and counter, all in one unit. Primarily aimed at basically laboratories which had limited space and limited power, because this is what 20 years old. Back in the day, these things would have been a lot more bulkier, and it's here to help with space. Instead of having 4 separate instruments, you just have one box which is meant to do everything. So let's get on with it. What we got at the front, we've got a frequency counter at top. Can go up to a couple of meg. Can do all the usual frequency countery stuff, compare, subtract, add, and what have you, various frequencies together. The frequency counter was actually internally hooked into the signal generators on these, so you could actually display what frequency you dialed in on the SIG-Gen. So that was a useful thing, and that was the only really useful thing that frequency counters in these are actually used for. Because if you use one of these with a scope or something like that, then scope would replace your frequency counter, and this becomes practically redundant. And that's why you don't really see these counters about anymore. They've really gone the way of the dodo, because the scopes can do all the functions that a frequency counter can. SIG-Gen itself is just a basic one, sine, square, triangle, up to from points of a hertz to 2 meg, and you got all the basic functionality on this. You've got these sweep functions, symmetry, offset, amplitude controls, and what you're not. 2 outputs, TTL and your main output, VCF input. So if you want to control the SIG-Gen with a voltage, then you can do that. Over on this side, triple output power supply, fixed 5 volt supply rated at 2 amps, 15 volt one that goes up to 1 amp, and a variable 0 to 30 at the bottom, and you can switch it in and out of your current and voltage modes and whatever, just like a normal everyday supply. Up in the corner here, box standard DMM, all your usual functions, millivolts, volts, milliamps, amps, no microamp range, only goes down to points of milliamps. So it does microamps, but the only auto range is down so far, and gives you everything in milliamps, which is a bit of a pain in the arse. Not particularly accurate when you're down in the microvolts range, but it's got other functions on it. You've got your cap test, logic test, diode tests, and what have you, continuity. Does auto ranging, and you can also set the ranges yourself, so manual setting of ranges, and you can switch between AC and DC, push of a button. So just basic kit, and just condensed down into one single box. So used to have about 50 of these, and they are very prone to going up in flames, because these were built on the cheap. All that you needed to do was shorten your inputs for any period of time, longer than a minute, and you'd see smoke and flame. So when I tear this down, expect to see a bit of damage inside or a few repairs. Let's start stripping this down. Basically, steel chassis, plastic front with all the knobs, and around the rear. these things do weigh a ton, by the way. I think they're about 15k each. On the back, the reason for the big weight is because it is a steel chassis, it's a steel frame and steel case, and it's got a big huge steel heatsink strapped to the back. Taking these apart, you go from the bottom to the top. Flip it over. 4 feet on the bottom. The front feet are, you can change them into stands. So that's your front foot, so you can make, you know, your feet at the front, so you can sit them up at an angle. The only trouble was these things did weigh so heavy that the feet did, after a while, buckle and break, so never bothered using them. Maybe I should do that on its back. Yeah, I've definitely been in this one before because that foot is loose on there. And it's around the wrong way. So that's a quick look there. Had about 50 of these units, and it's forever breaking down, like I said. And we always had about 10 of them up for repair. If you knew what you was doing with these, yeah, fine, no problems. But if you're a new person to electronics and you do short your inputs, yeah, you'd get into some serious trouble. So, that's the bottom off. Underneath, oh boy, what you can see down here is a signal generator. If I zoom into that, if I can, before I start stripping down the rest, let's show you this. So this is a signal generator. Basically we've got power coming in from our supply down the bottom here. All our switches going to the front panel. A few sockets and cables going to our front knobs and dials and our output terminals. As you can see, there's absolutely no microcontrol on that panel whatsoever. Everything is done purely using combinational logic and analog techniques, basically transistor amplifiers and whatnot, basically op-amp circuits and combinational logic to generate your square waves, some analog in there to integrate your square into triangle, and a few transistor amplifiers to convert that triangle into a square, into a sine wave, and they're all outputted through here. Hidden underneath this, when I take the chassis off, you'll see the output transistors, and I can already see on here, I don't know if you can, but I have replaced those in the past, and so I've worked on that board. And if you're, there you go, this is one unit which needs to be repaired, because if you take a look here, we have resistors which have been burnt, which are burnt out, and they're in actual fact the load resistors, if I remember rightly. You can probably see that. Let's get a closer view on that. There you go. You can just about see that. We've got one resistor just up here, 1 watt, or is that half a watt resistor? Just there, can't remember now. It's been too long. That has actually been burnt out, and we'll probably see some more burnt out resistors on that board eventually. So that's from shorting out the supply, and basically all that power's been dumped. Instead of going out, the unit's all been dumped internally and dropped across the inputs, the output impedance. So let's finish stripping down this unit. And 3 screws across the back, 2 on the sides. see if we can actually see this on the camera. I forgot to flip my screen round so I can see what I'm doing. Yeah, that's fine, lovely. Right then. This case was a tight fit on these units, and I did shout some expletives quite a few times getting this off, so I'd end up dropping it on my feet trying to strip the front out. Hopefully it's not going to do that this time. There we go. Chassis open. And inside, what we have, it's not a lot to view, really. So we've got a primary transformer down here, secondary transformer here. Primary one goes off to a DC supply, which is this section at the top. Secondary one goes off to also a DC supply, because the actual DC supply and power supply for the entire unit is all integrated into one. Bit of a screw up there, I think, because if your DC supply goes, or if something goes wrong with that, then it definitely did use to affect the power going back to all the other units. So if you lost the DC supply, you can guarantee something else isn't going to be running right. So down here we've got a function generator, function generator's on the bottom. This is our frequency counter. Single chip solution. Basically we've got a crystal going to single chip, which is a micro controller. Let's see, I imagine it is. Can't see too much on there at the moment. Probably some stuff on the underside of the board as well. I think that's in actual fact just to control the front switches. The microcontroller will be underneath. Can't read off that too well upside down. Take a look closer when we strip that board out. Again, power supply board, regulation down here for the various voltages at the front. Big ass ceramic resistors. These are for measuring the currents and setting the current limits for our three outputs, as well as the limits and short circuit protection and what have you for the various other units as well. That big heatsink at the rear, you can see that. The only thing that's really strapped to that is 1, 2, 3, 4 FETs, if you can see in there. It's got 4 FETs strapped across the back. There's a big ass heatsink, and this thing is absolutely huge. You know, it's about what, 15-20 centimeters long by about 10 deep, just for 4 little components. And if I remember rightly, these didn't get very hot anyway, because they are way overrated for this, because you're only really dealing with sodding milliamps primarily in this circuit, and you're only really going up to amps on the DC supply. So let's start stripping this back, and if you're wondering where the multimeter is, well, it's a single panel hidden right back here in the front fascia. So let's start stripping this apart. Go from the bottom up, because it's easiest, I think. So, start unplugging wires. This wire goes off to our main output. Couple here, we've got a few headers here, cables. This is actually going to our amplitude control and function select, so that these can come out. This wire here, over here, if you can see that, that's actually connected to our function generator display. So that's what passes our clock signal back to our function generator. It's not shielded or anything. And Yeah, so that's a bit crappy. We'll pull that out. Down here, these are mainly power. So we've got a couple of different power lines running in for various sections of the board to isolate to your analog ground, digital ground, and your various power for your waves, all decoupled with a couple of electrolytics. So they can all come out. Now I imagine the chunkier one goes off to the panel at the front. So this one will be power, this one will be power and switching for front set of switches, frequency multipliers. Everything's unplugged, I think. Let's start unscrewing this. There it is. That's our other screw in here. Let's slide this board out. Everything is modular in these things. That is your function generator. One single-sided PCB with, looks like down here, an extra 2K resistor that was plugged across to the root and soldered in place at some point. And instead of paying out for double-sided, they've opted for some jumper wires, some shielded jumpers, just to hook across from the low resistors to our output circuitry. Let's zoom in on this and take a look at it in a little bit more depth. Right, and so as you can see, do have some scorching on this board. If you can see that over in this area just here, we've got some scorching there. These were these are resistors setting the current values for our main output. This is our output stage. Just basically a push-pull amplifier, match pair transistors, a couple of resistors to set your set the currents and voltages on there. And this little circuit was one of the main culprits that was always failing. These transistors here, power transistors, were in actual fact the old metal can ones with a heatsink strapped around them. They were woefully underrated, and if the if the input was shorted out, basically your output stage would overheat, and these transies would blow pretty quickly. They'd also overheat and desolder themselves from the PCB and drop out. So these aren't the original ones. These are BD132s and BD131s, match pair power trannies. And down here, these were 22 ohm 0.33 watt resistors that would always go on that side, because you'd short it out, you'd get maximum current flow. Too much current would flow through these resistors, burn them out and literally set fire to them. You can probably see that from the scorching on the board. Blow up, they would go, the trannies would go, huge currents would flow in the circuit and the whole thing would just go up. Yeah. As I said, over on the opposite side, down there, this one's not so bad as some of them. These are your output impedance. This is your impedance select from 50 ohms to 75 ohms, and these ones resistors are just what govern the output impedance of your signal generator, just a resistor, nothing more. And that wire underneath is actually linking these back, is linking the power amp through to this section here, which would then pass it back over here to our output, which, you know, is a bit shitty, but yeah, they opted for cheapness when they actually built these. That's not as bad. Some of these, when they would go, would really go, and it would melt out the actual switch here, and so you have to replace the switch, but it's not too much of a problem. Going around the board, you can see that there's absolutely no resonators, no crystals, no nothing for precision timing. Everything was done using basically combinational logic. So we've got a let's see, let's zoom out, point out some of these chips. So we've got basically NAND gates down here, the 7400s. We've got some, what other ones, 7486s, what are they, exclusive or exclusive NORs. You've got some 7402s, I think they're, what are they, 7402s? Are they NORs or are they Hexinverts? No, I think the Hexinverts were the 04s, weren't they? Well, I can't remember. It's been so long since you used combinational logic chips on their own. But basically, this section is just basically generating your TTL outputs and square waves fed into the analog circuitry, which is all down here. Now in this section, these are just quad pack amplifiers down here. Over here we've got a transistor array. So these amplifiers are 14532s, 14051s, 14501s. Yeah, they're quad pack operational amplifiers, and down here we've got a transistor array CA3046, which you can hardly get these anymore. CA3046s, we actually used to do an experiment with those, we still do, and we're just recycling those components now, and that experiment is going to be gone soon, but yeah, that's definitely a transistor array in there. And that's basically the signal generator. There's not much to it. Single-sided design. That's the rear side. As you can see, that's where the output stage is. You can see the PCB's had a bit of a hammer in there. Got scorching on the underside. Down the opposite side, down here, you can see again a slight scorching where other components are overheating as well around that area. Just there, those solder joints are on their way out. It really is a cheap unit, but 20 years ago there were absolutely tons of those types of things out. A de facto standard signal generator at the time. Nowadays, most of that will be replaced by a single microcontroller or a D2A or something. Let's get back with the other stuff. Get back to stripping out more. Let's do the power supply next. So to take out the supply, I'll take out the signal generator, the frequency counter board. So used to not saying frequency counter because you never use them anymore. Let's do the supply. should have really attached the cables first because there's 1,000,001 cables plugged into this thing. So let's just rest this like this for the time being while I unplug. Need to keep my fingers on this, stop it from dropping out. Out comes the, oh, we've got another one there, the power supply. One power supply out. Basically we've got down here is all our connections going to our front panel, just there for the colour coded yellow and red. Yeah, it should be really yellow, it should be red and black really for the terminals. They go off to the terminals in front of the unit for our DC supply. Two more here, smaller ones, 3-pin terminals. They go off to the voltage knob and the current set knob. One supply cable here which goes off to, one goes down to the signal generator, the other one goes off to the front panel, the LCD display of the power supply. This one here goes off to FETs across the back, basically just to regulate the supply side for our power supply. Another one at the back here, this is going down to the rear of this board where all our bridge circuitry is, so that's our primary input from the main transformers, our mains input. So we've got basic mains input comes into here, gets dropped down, goes off to our supply, and it's also split into this secondary transformer which supplies the other parts of the circuitry. So it uses two different transformers, a primary one and a secondary one, for isolation and what have you. Not too sure why they've gone so big. Yeah, who knows. Bit overkill on supply, so let's go on take out the frequency counter board. We've got the yellow and white which goes down to frequency generator. This was the output of the frequency generator into the frequency counter to display the generated frequency. So let's start stripping out this one. Then we can get to grips with these two circuits before we go on to the front panel. I'm not too sure if I'll take the front panel fully off, I might just do that from the rear. Camera zoomed in. See, that most of this stuff is out now, and you'll be able to clearly see what's inside there. Extra one, probably underneath. Oh no, there we go. There is our frequency counter. So, double-sided board on the frequency counter, single-sided for every other board in here. Spinning this around. Just underneath here is our DMM circuit board back here. This is just for the display. I'll take this one out. Two screws holding the display and the frequency counter in place. Goes our frequency counter, just a load of LEDs on there. And that is our DMM back here. Let's see if I can take this out. That comes off. One little piezo speaker. Excuse the sound of that. A little bit of metal across the back just for some shielding or protection or something. If it is shielding, that isn't really going to do very much because it was open. A couple of things here. Okay, so we've got our battery clip. This is actually going off to a battery pack at the rear here. The DMM isn't a mains supplied unit. Unfortunately, I'm not going to be able to get this out too well because it's actually hard soldered in to the fuses at the rear here, which are underneath this box just here. Got the fuses here for the DMM. They're actually been hard soldered in. So we can get out anyways. The mix has definitely been screwed in quite a bit. Can we get this out? I don't know, it's a tough boy. Doesn't want to shift. I left a couple more in down the bottom here. No, I neglected to take out. So many cables soldered into the rear here that they're obscuring some of the screws. That's it. Wants to go, but it's still in there somewhere. These screws are all missing one right at the very top. And the others here. There's 100 of these screws holding the multimeter in place. I can't believe how many there are. That post is screwed through to the front chassis somehow. Yep, it is. One spacer that's actually holding the front on. And there we have it. One multimeter. Which is all still soldered, hard soldered inside. I'll sit that one there for the time being. We can have a look at it later on when I zoom in to that. There we go. So then, there we have it. So let's get down with each of these boards in turn. First up, the supply board. As I was saying, this is a combined supply. It's combined because it actually supplies power to the entire box and to the front DC supply. At the rear, this is where all our mains rectification takes place. So we've got our couple of bridges at the rear, 1, 2, 3 bridge circuits, filtered, 3 of them. Why? 1 for the power supply, 1 for the signal generator, 1 for the frequency counter. They're on 3 separate circuits on this board. Basic voltage regulators, 3 voltage regulators on this board. 1 for the variable, 1 for the fixed 15 and 1 for the fixed 5. Current sense circuit down here for the variable supply, and a little bit of short circuit protection actually built in to these regulators. So they're actually using short circuit protection on the regulators themselves. There's no other protection on this whatsoever. Apart from the chips on here, which are just the regulators, you've got some ceramic, some cement resistors. These are 0.1 ohm for current sensing, so we've got 0.1 ohms and 0.5 ohms, all 5 watt ones. These ones did burn out occasionally during, if the input was shorted. Have high current flowing through these. They'll be detected. It switch the voltage of the front panel off, but you still get high current flowing through these, and eventually they did burn out. It's always a pain in the buttocks. Smoothing caps and some voltage regulation on the strap to the heat sinks. Let's have a look under the board. As you can see, atypical isolation. Board hasn't been cut or anything, but the primary side, the actual rectification from the mains and whatever, is completely separate from the regulated power supply back here. So you've got your mains coming here, getting smoothed off, and then being passed off to the various areas. And yeah, that's your supply board. It's the bog standard DC supply. Regulated supply, not switch mode, I might add. Moving on. Frequency counter. That's our front panel for the frequency counter. 1, 2, 3, 4. Hold on. Alright, back again. Someone from the office just had Vicky in here. Didn't want to star in the video for some reason. Anyways, yeah, so we've got our front panel for our frequency counter. 1, 2, 3, 4 7-segment displays, a couple of LEDs. Looks like 3mm LEDs, a few square ones down this end, just for displaying the various functions and what it's set to, and no resistors on that board whatsoever. All of those current limiting resistors are down on the signal generator side. The frequency counter side. That's the rear of the board. Double-sided board, just to make life easy for the for laying out. I don't know why they didn't use double-sided on the signal generator and the power supply. Could have shrunk it down quite a lot. Anyways, moving on, we've got our main board for the frequency counter. Double-sided board. A couple of SMD transistors and resistors on the underside there for driving the display. All of the main workings for the frequency counter are underneath here, this shielded section, and the controller with a separate crystal by the looks of things. Let's open up this and see what's inside. Let's open up this shielded section. And lo and behold, there's not much in there. As I said, this was a single chip solution. Down here, what have we got? We've got a relay, 2 amplifiers, and 2 single op amps. That's all that's in there. A few caps, basically filter circuitry, converting any sinusoidal and whatever that you've got going in there, basically trigger circuits to convert them all into squares, a nice square wave or something to do edge triggering on the microcontroller. So you can do all your counting functions. It's down here, and basically all that this is doing is counting pulses. So you count the pulses go in over a set time. You can work out the frequency, and yeah, that's all that is really doing. It is a really low component count frequency counter. Double-sided, as I said, driver circuits, circuitry all on one side, processing all done on the other side. A little bit of analog just for triggering, Schmitt triggers and what have you, and wave conditioning and whatnot before it's fed into your MCU. What more can be said about that? Absolutely bugger all else. That just leaves with the DMM. Let's try and pull this into view on the back of the unit. Boy, that's a heavy bugger. Even with everything out of this unit, it still weighs a ton. So then, down here, let's move it in because it's still attached slightly, is a digital multimeter. Basically it's a double-sided circuit board, single LCD. Can we look underneath this at all? We should be able to. Usually these are, you can unclip them. Let's take the shield off, can we? Oh yeah, I might be able to. If I take this spacer off, I'll just use a pair of bloody cutters just to loosen that off. Wrong tool for the job, but who cares? We're pulling it apart. Right then, so it's a display, LCD display, and by the looks of it, just attached by two wires. So serial interface to the LCD. And what am I about serial interface? Oh well, there we go. These are all the connectors down here. Parallel. No processing whatsoever on the screen, so that'll be a single-sided board. And down here, this is what does all the processing. Looks like a you got a Max 134 down here. Down here, you can see that Max 134. This is basically your multimeter, single chip multimeter solution. Over here, this is in actual fact memory. It is just a couple of K of memory and a yeah, that's it. Opto isolation, because this can actually be fed to a serial port at the rear of our unit. Controls. Over here you can see our selector. Selector is actually designed on the PCB itself. This will be where your control knob will sit. And if I zoom into the front of the unit, you can see it right there. That big orange disc is what sits on top of our multimeter, on top of this multimeter, on top of this PCB just here. So it's just a cheap ass solution, multi-way rotary switch. That's part designed on board, so all that you've got to do is manufacture a bit of plastic and a few copper contacts. What else we got? A couple of crystals for timing functions and whatever for our for the actual digital to digital, analog to digital conversion. There's not much else on there. Protection wise, we've got our input protection down the side here. That is it. Yeah, so there's not really that much to it when you look at it. selector switches for selecting your different functions, and yeah, bog standard. On the AC side, you've got a little bridge circuit there, I imagine, and I'm not too sure what this, that's our current shunt, if you can see that. Don't know if you saw the other videos what I did on you know, basically intro to electronics and talking about wires and using wires as resistors down here. This is in actual fact a piece of metal, so it's just a metal conductor along here that's being used as a resistor. So this is a known resistance, and you can measure voltage across your known resistance to work out your current. So you know, so that's one way of working out current. So you've got current flowing through it, measure voltage with your microcontroller, and you get a equivalent, you know, current equivalent measurement. That's basically all there is to a multi-unit. And as I said, that was battery powered. And the other panel that I haven't took out, which is a pain in the ass to get to, is this one down here. That's the supply, the DC supply display. So you've got a 10-turn knob for the voltage supply. You got another 10-turn pot down here for the current, and your LCD display, which is very similar to this one here on the front panel to display your voltage. That's basically what the unit boils down to. 4 circuits, basically stripped out of, you know, so what it'll be 4 instruments stripped down to bare bones and then reboxed into a steel chassis. And that's about it. And if anyone is interested in looking into this anymore, because we have so much bloody trouble with these units, we got the schematics for the actual multi-unit themselves. There you go, the Max 134, upside down. That's the DMM. If you can see that. Not particularly clear because it is A3, I'm zoomed right in at the moment. Let's zoom out. There we go. So if anyone is interested in designing your own kit, I've got various circuits and what have you for old kit, and yeah, some service manuals as well. So that's for the Mark II. Anyways, I'm gonna leave you with that. As you can see, it's a complete mess now. All the circuits are everywhere, screws all over the benches. I'm not exactly the most cleanest, tidiest person when it comes to stripping down and tearing things apart. But yeah, I will leave you there, and I will see you next time.